Good morning, everyone. I'm Soutaro. I hope you find me on the stage at the last session. And yeah, today I'll be talking about the API for docs, about the documentation that is implemented in RBS and Steep. I'm one of the Ruby committers, I work for RBS. It is a type declaration language of Ruby programs, and it is also a name of a gem that passes the RBS files and do some works on that. I developed Steep. It is a static type checker. It is built on the top of RBS. I'm a software engineer at Taimi, and I've started writing a series of articles for a magazine called Software Design. It's about the types of Ruby hackers. So you will find this one at the Sasada-san's bookstore in this Kaigi, the second floor. 僕の記事が5月号から掲載されるんですけども、5月号今日発売されるっていうことで、さすがにここの本屋では買えません。残念です。なので、皆さん帰りにその辺の本屋で買えるといいと思います。Okay, so let's start with the update of RBS and Steep since last RubyKaigi. RBS 3.9 and Steep 1.0 are the latest versions. Generic type parameters can have default values in RBS 3.6. You can make some types generic without breaking existing type definitions. Steep 1.7 allows ignoring some type errors. If you cannot find the way to fix that type error, you can just ignore it by writing some comments. Steep 1.9 updates some Steep file DSL, so it now allows some better project organization, and it may improve some type checking performance on CI settings by running the type checking some parts of your project parallelly distributed on the computers. The resolve type names magic comment is introduced at RBS 3.9. It will make the RBS file loading faster. You can make types, methods, and some constants deprecated. The Steep 1.10 reports some diagnostics if you use those deprecated ones in your Ruby code and RBS type definition. -- refork option is available in Steep 1.10. This is experimental, and we hope that it reduces the memory footprint the RBS is eating. This is done by Poke-san. And another one is receiver type narrowing. It is available in Steep 1.10. And this is by Komiya-san, and he had a presentation related to this in the first day. So I think you're wondering something is missing. So inline RBS declaration support is not finished yet. I have been working for RBS 4 and Steep 2, and I hope these new versions will come with this feature. So it means that RBS that RBS gem itself loads the Ruby code with inline type declarations. So you don't have to generate the RBS files using RBS inline gem. But I'm sorry that it's not finished yet. So you can find some progress related to this on the GitHub repository, but it's not available yet. So these are some of the latest updates on RBS and Steep. So moving on to the main topic, the documentation feature of Steep. Steep provides some features to help programmers, to help you reading the documentation associated to the Ruby program components, class, module, methods, some type definitions in RBS. So let's see how these features are working. The first one is hover. It shows the documentation when you point something in your source code by your cursor. When your cursor is on a class name, it shows the documentation associated to the class. So the screenshot is about the comment block class. It is the part of the RBS gem. If your cursor is on a method call, it shows the documentation of the method. Completion pops up when you write the name of the method. So this example shows that when I write map, and it shows the list of the methods that contains map. So map, map band, flat map, filter map. And you also find that the documentation is the documentation of the first selection. The first item is shown. It is an array map method. Signature help is another feature to help you writing the method call arguments. It works for when you write the argument of the method call, and it shows the possible parameter list, and it also shows the sum of the method, sum of the documentation of the method. So the source of the documentation displayed in the editor is the comment written in RBS files. You can put some comment of the class declaration, comment on attribute definition, comment of methods. You can format them in Markdown because the language server protocol natively supports the writing something in Markdown. So you can write like this. Those features are implemented on the top of an internal API in Steep. RBS files are loaded into some internal data structure, and the editors send some request to show hover to show the completion and thing via a protocol called language server protocol. The language server, it is implemented in Steep. It receives some request from the editor and do something to query the documentation, and it sends back to the editor, and the editor shows the content to the user. This is a bit different from some traditional documentation tools like RDoc and YARD. So they generate HTML, PDF, or some human-readable documents. But what is RDoc? I mean, the word means some different aspect of the tool. We call the syntax of documentation embedded in Ruby and C code RDoc. This is one of the most frequently used user interface. So when you are writing some Ruby code, you sometimes write some comments in the RDoc syntax. And we also call the output HTML files RDoc. This is another user interface. So we use that HTML files to understand the overview of the library or to understand the behavior of a method. We also have some internal structure. It is the implementation of RDoc gem. It has some classes and modules, and it loads some documentation from the Ruby source code and generate some output HTML files. But this is implementation detail, and the end user don't need to understand them. RBS documentation system also has similar structure. RBS files are the input. It has some internal structure. The output is a bit different. We consider the documentation fragments that is sent to the editor is the output. The output is generated on the fly. That is triggered by the end user's interaction on editors. The editor sends some request to the server, and the server generates something. So the generation is done just in time. And Yeah, in this presentation, we focus on the internal structure. I don't discuss the concrete documentation syntax. I don't talk about the output formats, but I'm going to explain the implementation of the internal structure of RBS and STEEP today. So these are the components that is related to the documentation features. ASD, parser, and environments, they are part of the RBS gem. Type checker and displaying the docs are implemented in STEEP. So let's start with the ASD. This is some of the syntaxes to declare the RBS types. So on the left, we have class declaration. In the middle, we have the method definition. So that is the def syntax in RBS. So they have comment attribute. It keeps the comment Ruby object. And we know that a comment is associated to some of the constructs in RBS files. The comment class is very small. It's on the right. Essentially, it has only one attribute called string. So it contains the content string of the comment. The next one is parser. The RBS parser is implemented in C, as you may also already learned at the presentation by Alex from Shopify yesterday. This is internal data structure called comment. This is a purely internal data structure. It's not exposed to the Ruby class library. So this is just to keep the track of the comment tokens during the parsing of the Ruby source code. It has start and end position, and it keeps the list of the comment tokens. So this is one comment value. One comment value may have several comment tokens. In this case, there are 5 tokens. And the last one is next comment. This is a linked list. So the next comment points to another comment in the source code. The parsing implementation is something like this. So this is a function that parses the method definition syntax called the parse method def function. The get comment function here retrieves a comment in the source code. So the comment we want is identified by the line number of the current token. What is the current token here? It is the def token. So the get function, the get comment function finds a comment ending at the just below the current line. So this is the comment. The get comment function constructs a comment Ruby object and returns it. So finally, the value of the comment local variable is a comment object, or it may be new if there is no comment. And then finally, it is passed to a function that constructs the ASD object. In this case, it is the RBS ASD members method definition. So this is how parser attaches comments to the ASD objects. We have ASD objects now, and they have some associated comments on each class declaration, method declaration, attribute declaration. So let's see how can we find the comment content using some class names or class name and method name. Environment is a set of RBS type definitions, and RBS gem parses the RBS files and puts them into some environment object. We convert the set of RBS declarations into a data structure called definition. So definition has methods, variables, some ancestors, the ancestor relations between class and modules. So this line calls a build instance method. It constructs a definition object for instance of a string class. There is a method. that keeps the method object for each method. Too many methods. And the comment method returns an array of comment objects. We have type checker in Steep. Type checker scans all of the Ruby programs and assigns the type of each type to each node. The constant is string, and the type checker knows which class the constant is associated with. It is string class. So it looks up where the class declaration, that string class is declared, and finds the comment associated with the declaration. It's almost the same with the method calls. The type checker detects which method overloads may be called on the method call. So in this case, this one is the overload. And again, we find the comment that is associated to the method definition. The last part is the communication with the language server protocol. This is an example of hover request. It has a file name and the cursor position, line number, and character index. The language server finds which node is located at the position, and it fetches some documentation that is related to the node, and it returns the JSON object that contains the formatted documentation in Markdown. So this is an overview of the implementation of RBS and Steep, and yeah, it will help you understand what is happening under the hood. And yeah, it has a problem. Steep starts type checking when you edit comments, when you only changes the comments in RBS files. So this is a demonstration that shows we're editing some comments on the absolute question method, and you will find at the bottom bar, it tells the Steep is type checking the source code. So this is weird. So because this is just a comment, we don't add any type definition, any new class or module, no method is added. We are not changing the type of methods. It just updates the docs. So nothing will be changed on the type checking result. And yeah, why we need to run the type checker again? For the type of constants, it's fine. The type of the constant is a singleton of string, and we can easily extract a key to identify which document we need to show. It is a class name. The string is a class, and we can look up the documentation from the RBS files. The problem is on the method call. Unlike the case of constant, it currently directly points to some internal overloading data structure. And the internal data structure can be resolved to the comments. This is the same. So the problem is here. When RBS file is changed, the internal overloading data is updated because it might change some type checking result. And we have to run the type checker again. So yeah, I say the feature is something like an API in the previous slides. But when we see the implementation closely, we found there is no clear boundary between the doc system and the type checker. We may solve the problem by introducing some clear API between the doc system and the type checker. So we would call that API index. So when Steep loads RBS files, it also updates index. It registers some documentations to the index. If only comments are changed, it updates the index, but it doesn't need to run the type checkers. The language server pulls the documentation from the index using some identifier. So it doesn't use some internal data structure, but the communication between the index and the type checker is done through some identifier. Another benefit of using identifier is that index may be reused after the server restart. If we can make the identifier serializable, like just a string or something, then we can save the index and the identifier to the disk, or it may be loaded from the disk later, or maybe we can distribute the index via the internet. So the index will be like this. So we have, for example, the class documentation and method documentation. We have the register and query methods. The docs of the class can be registered to the index. The name of class is the identifier. So this is very simple. The docs of a method can also be registered to the index, but the problem is, what is the identifier of a method? So you may be wondering the string hash encoding or the array.new. So these notation are standard in Ruby community. So yeah, it works fine for some methods like string hash encoding because it only has one overload. But how about the referencing of array class? There are 3 overloads in the RBS declaration. So it's not clear which overload is pointed with that notation. But in fact, this example is okay. So because there is only one def syntax here. So all of the overloads shares one documentation content. The problem is that RBS allows multiple def syntaxes for overloads. This is an example. The foo method has 2 def syntaxes in the right. The first foo call points to the definition in a.rbs because the argument is string. And the second foo call points to the definition in b.rbs because it's called with integer. Steve currently handles the 2 foo call overloads correctly. So we need something to identify the overload for the index API. The hash method name or dot method name notation is insufficient for this. So how we can find the good identifier? How about using the file name and the line number? So we have 2 definitions, and the first one is in a.rbs. The second one is b.rbs. It's good. But the problem is that the line number may be changed when we edit some comments. So we may add some new line in the comments, and we will change the line number of the def syntax. So we have the second one is a b.rbs, the fourth line, and it doesn't have the def syntax. Another idea is simply using the index of overload. We have some list of overloads in January, so we can call the index 0, overload 0, overload 1, overload 2, so adding a number after the method name. The first one is overload index 0. It points to the integer case because the overload added with the triple dot keyword comes first. So at mark 1 is the string case. And this doesn't work well again. So because the overloading order depends on the file loading order, and the file loading order is unspecified in RBS. So when c.rbs loaded before b.rbs, the integer overload comes first. If the b.rbs is loaded before c.rbs, the symbol overload is the first. I mean that the overload index is not very stable. It may change after server restarts, or if I change some of the implementation of RBS gem, so it will be broken. Another problem is that it's not human readable. It's not very clear which overload it is pointing to. So finally, I think that using the method types directly is the solution. We can add some method types after the method name, and it will solve the problem. So it's very clear which one is which def syntax. It's yeah, it's very straightforward. But when the type of method is changed, it means that the identifiers should be invalidated. It means that we should run the type checker again, but this is fine because we anyways need to run the type checker for the up-to-date type checking results. This is similar to method descriptor in JVM. So JVM uses some engineering names qualified with parameter types and return type. So this example is that hello method definition in Java at the bottom. The top is the engineer JVM method descriptor. So it has a type of parameters in a blue and green part, and the orange part is the return type. This is almost the same to what we will do, but instead of using some cryptic but compact type name notation, we can simply use the RBS method type notation. We need some normalization because the RBS method types may have some redundancy. So we should drop the parameter names. It's about some documentation, and it doesn't change the type checking result. The keyword argument ordering would cause some confusion too. So we should solve the keyword arguments. And yeah, it will be fine. So the normalized method types can be used to identify the overload of methods. It is a string, so we can save to file or load that from files, or we can compare them as a string. It will be super easy. It's almost implementation agnostic, and it will be stable after server restarts, after some gem updates also. So using this identifier, we can separate the docs system from the type checkers. So the two components can be connected by the index API. Let's see the constant example again. So the type of constant is a singleton of string, and the key to fetch the documentation is a class name of string. The method call is the same. So the type checker detects the overload that we've called, and we now have an identifier of method call, the identifier of method overload, and the documentation can be pulled from the index using the identifier. So yeah, so okay, so everything is fine, and we can start the implementation, and yeah, it's not finished again, so I believe it works, but yeah, it's not confirmed yet by implementation. Another topic we can discuss is that if the index can be used by other gems like RDoc or YARD, so it would be really great if RDoc can register the documentation to the index, and Steep and maybe RubyLSP can use the index to show the documentation that is written in RDoc directory. But I'm not sure if this makes sense or not. So we discussed the key of the index, and I think we solved the solution. We solved the problem, but we haven't discussed the content of the index. So RDoc, YARD, RBS, they have different documentation content. So the problem is that how the content format is, the content format should be to cover all of them. Another possibility is using the index to store the definition locations or reference locations. So we can store the location across what method is defined in the code base, or the opposite, where the class or method is used in your Ruby program. And yeah, then this index can be used to implement the go-to definition or go-to reference features. Okay, so we see the overview of the documentation feature of Steep and RBS. I also explained some of the implementation and discussed some problems. And I also shared the idea to implement the documentation index. The key is the design of the method overload identifier And I hope the API might be used by other tools too. So yeah, that's it. So thank you for your attention.